Every Magento upgrade runs the exact same command, and it's supposed to be safe to run it as many times as you want. Run setup upgrade once, or run it 5 times in a row, and the result on disk and in the database should be identical. That's not an accident, and it's not extra code every module author has to write by hand. It's a real class called PatchApplier, backed by a real database table called patch_list, that Magento's own setup scripts implement in exactly 2 files, DataPatchInterface and SchemaPatchInterface. Today we open the real source behind both how a patch declares itself, how Magento remembers what it already ran, and how one patch can depend on another without a hard-coded module install order. Every file and line comes from a real git checkout of the pin 2.4.9 tag. Welcome back to Magento Development Deep Dive. Part 8 covered declarative schema, the XML files that describe tables. Part 9 covers the other half of every module's upgrade story, patches, the PHP classes that actually run logic during an upgrade, whether that's altering a table or seeding real data rows. We'll trace a real schema patch, a real data patch, and the exact machinery that guarantees neither one ever runs twice against the same database, using grand truth line numbers from a local checkout of the pin 2.4.9 tag. By the end of this part, 5 things should click. Why Magento splits patches into 2 separate marker interfaces, SchemaPatchInterface and DataPatchInterface, instead of one generic patch type. What a real schema patch looks like end-to-end, using an actual shipped example. What a real data patch looks like end-to-end, using another actual shipped example. How the PatchApplier class decides, before running a single line of a patch's logic, whether that patch has already been applied. And how the patch_list table plus the PatchRegistry class work together, so patches from different modules can depend on each other without every module author hand coordinating an install order. Strip away the code, and every patch's lifecycle is 5 stages. Declare: a plain PHP class implements either DataPatchInterface or SchemaPatchInterface, and nothing else marks it as a patch. Register: PatchRegistry reads every patch a module declares, and resolves each one's getDependencies method into a real dependency graph, so a patch that needs another module's patch to have run first will always run after it. Check: right before running anything, PatchApplier asks a simple question: has this patch's exact class name already been recorded as applied? Run. If not, the patch's own apply method executes, wrapped in a real database transaction for data patches. And record: the instant it finishes, its class name gets written into one specific table, patch_list, permanently, which is the entire mechanism that makes rerunning setup upgrade safe. A few things help before we dig in. Part 8, on declarative schema, is directly useful. Schema patches exist specifically for the schema changes that a plain db_schema.xml file can't express, like the multi-store table creation loop we're about to look at. Either a real Magento 2.4.9 checkout, or the GitHub tag open in a browser tab. Basic familiarity with PHP interfaces and database transactions is enough. No prior Magento 1 install script or upgrade script experience is needed at all. This system fully replaced that older approach. These are the real, complete marker interfaces. Neither one adds a single method of its own, both just extend the same base, patch interface, which is the thing that actually requires an apply method. So why have 2 interfaces at all, if they're identical? Because PatchApplier checks which one a class implements before deciding how to run it. Data patches get wrapped in a database transaction with rollback on failure. Schema patches don't, since DDL statements in most databases can't be transactionally rolled back the same way anyway. The type itself is the routing signal. This is the real apply method from EnableSegmentation, a genuine shipped schema patch from the catalog module. It loops over every store in the store table and, for each one, builds a per store index table name. Notice the if statement is table exists is checked before create table ever runs. Even though PatchApplier already guarantees this whole class only runs once, the patch author added a second, independent safety check right here. That's not redundant paranoia, it's a real defensive pattern worth copying in your own schema patches. This is the real apply method from install order statuses and initial sales config, a genuine ship data patch from the sales module. It's the thing that actually seeds real order statuses like processing, complete, and cancelled into a fresh database. It delegates the heavy lifting to a sales setup helper object, then builds real status and state rows. And notice getVersion, a separate required method returning a plain version string. That's what lets Magento's backward compatibility layer skip this exact patch on databases that already got this data the old way, through a setup script tag with that same version number. This is the real core loop inside applyDataPatch. Every patch class gets instantiated fresh through the object manager, then immediately checked with isApplied. If that returns true, continue, skip straight to the next patch, no apply call, no transaction, nothing. Only unapplied patches make it past that line. And for any patch that isn't explicitly marked non-transactionable interface, the whole apply call gets wrapped in a real begin transaction and commit pair, with a rollback on the error path we're not showing here so a failed data patch can't leave half-written rows behind. This is the real, complete isApplied method, and it explains why every patch class also has a getAliases method. It first checks the patch's own current class name against history. But if a patch was ever renamed or moved to a new namespace, checking only the current name would make Magento think it needs to run again on an existing store. So isApplied also checks every declared alias a previous class name, and if any alias was already recorded as applied, it immediately fixes the new name into history too, and reports the patch is already applied. Renaming a patch class is safe, as long as the old name is listed as an alias. This is the real fixPatch method, and it's the single place a patch's class name actually gets written to permanent storage one row, in one real table, patch_list. Look at the guard at the top. fixPatch itself throws a logic exception if the patch is somehow already marked applied. That's a second, class-level idempotency check sitting directly underneath everything. PatchApplier already does 3 separate layers now, all agreeing a patch must never run, or even get recorded, twice. This is the real core of getDependencies on PatchRegistry. It calls each patch's own static getDependencies method. The same method EnableSegmentation returned an empty array from earlier and walks the result recursively, using a cyclomatic stack array to detect the one failure mode this graph can't tolerate, patch A depending on patch B, which depends back on patch A. If that ever happens, it throws immediately rather than looping forever. This is exactly how one module's data patch can safely declare a dependency on a completely different module's patch, without either module's author hardcoding an install order in Composer or module.xml. A few things trip people up here. Rename a patch class and forget to list its old name and get aliases, and Magento has no way to know it's the same patch. It will try to rerun it, and fixPatch's own guard will only save you if it somehow still matches the old registered name, which it won't. Schema patches don't get PatchApplier's automatic transaction wrapping the way data patches do, which is exactly why EnableSegmentation adds its own isTableExists checks copy that pattern in any schema patch that isn't naturally idempotent on its own. Get version only matters if a patch is replacing an old install or upgrade script that used version comparison. Brand new patches with no legacy history don't need to implement patch version interface at all. And a circular dependency between two patches getDependencies methods throws a real logic exception the moment setup upgrade hits it. That's a design signal to restructure the dependency, not something to catch and ignore. Let's pull this back together. DataPatchInterface and SchemaPatchInterface are marker interfaces with no methods of their own, but they route a patch through genuinely different execution rules inside PatchApplier transactional for data, not for schema. A real schema patch and a real data patch both boil down to the same shape, one apply method doing the actual work, one getDependencies method declaring what has to run first. PatchApplier's isApplied method checks the real patch_list table by class name and by every alias a patch has ever had. PatchHistory's fixPatch method is the single place a patch's name gets permanently written, and it refuses to write the same name twice. And PatchRegistry's getDependencies method turns every patch's individual dependency declaration into one ordered, cycle-checked graph, which is what lets patches from entirely different modules depend on each other safely. That's the real machinery behind Magento's data and schema patches, straight from a git checkout of the pin 2.4.9 source, every file and line verified against that exact commit. Part 10 moves to the view layer layout XML, and how Magento assembles an actual page out of layout files, blocks, and containers. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 10.